Very good evening, everyone. I hope you guys are able to hear me, see me. My voice is clear. You're able to see me properly on your screen. Can you guys quickly put that into the chat? Please confirm that in the chat so that I know you're able to hear me. I'll just wait for a second. I'll see for the confirmation to come. Hello. Yes. Can you guys please confirm if you're able to hear me, see me? Put that into the chat so that I can get started, people. Perfectly. Very nice. So very good evening, everyone. Today's session, we'll try to move on. There's some echo which is coming up. Let me see where it is coming from. Let me close all the windows. Good evening, everyone. And I have this. Okay. Just give me like 1 second. Cool. Great. So very good evening, everyone. Today we will get started with another important concept in the field of data structures and algorithm, which is called as sorting. Now, sorting is a concept which is very critical, very important, especially if you people have an interest in the field of data. If you have a field in the data science, data analytics, this concept becomes supremely important. And secondly, as per my experience, every 3 out of 5 questions which is being asked to you in the interviews, they will have or they will involve the concept of sorting to some extent. So now let's quickly get started with what sorting is. And we'll take about sorting algorithms one after the another. Okay? So before I get started, how are you people feeling? Kaisa chal raha hai aap logo ka? How are things? Let me quickly open my Zoom and let me share my screen. Cool. Are you guys able to see the screen, boss? Is my screen visible to everyone here in the class? Everyone is able to see my screen, Gar? Cool. So we are dealing with a concept called as a sorting. We know that, boss, at the end of a day, almost every company these days has become data hungry. Every company has become equals to data hungry. But with the data, we do only two things. No matter which device you are using, you're using a mobile phone, you're using a computer, but the data, we do only two things. We do the storage of the data. That's number one. Or we do the computation with the data. Now, as more and more we are growing, we want this storage to be more optimized, right? It means that we want to ensure that it takes less space and we are able to store more amount of data in the same space. That's number one. But just storage is not enough. Why are we storing data? We are storing data so that I can make use of this data to take some decisions, some informed decisions, some actions. So storage is important, but what becomes more important is this computation has to be done fast. This computation has to be done fast. And in order to do the fast computation, you will have to do the fast search. Because only when you go and search, then you go and do the computation. So if you have to do a fast computation, it means that you'll have to do a fast search. And things to be searched fast, the thing has to be sorted. And that's why it becomes very important. Whenever you feel that I have to go and fetch the data very fast, quickly, the data has to be in certain order. And the data is in that certain order, you're able to search faster. I'll give you a simple example. Let's take example of a pharmacy shop. Let's say that I start a pharmacy shop called as Med Shop, in which I have a big room. And in this room, I randomly threw all the medicines. All the medicines I have randomly threw. Now, if someone comes and asks me, boss, give me Dolo 650, do you think how much time will I take? Will I take very quickly? Can I get him the tablets, or I'll have to search through the pile of the medicine and it will take me a very long time? What do you guys think? Jaldi ho jayega ya it will take a long of time? Batao. What do you guys think? Will it be quick or it will take a long time? Since there will be thousands of the medicines and there's no proper order, if I have to go and find Dolo 650 among the pile of the medicine, it might take me hours to solve it. But normally you have find that medicine shop, they hardly give you the medicine in just few minutes. What is the secret mantra? What is the reason how they are able to quickly go and find medicine for you and get you very fast? What is that logic that they have used? What is the concept that they have cracked? What do you guys think? What is working for them? If you go and try to analyze that, almost all these pharmacy shop owners, what they do is that they keep all this medicine in a arranged order. What it means that they will keep multiple boxes. All the medicine with the A will be inside this box. All the medicine with the B name comes in this box. All the medicine with the name C comes in this box. So all the medicines are already arranged, ordered in the alphabetical increasing order. So that when you know that I have to go and find this medicine called D, you directly jump to the box which starts with D, and then you only have to go and search inside this box. So even in the real world, when you go and arrange things, when you go and arrange things logically, when you go and arrange things logically, you are able to get the fast search. You are able to achieve the fast search. And this arrange logically itself is called as sorting, sir. This is called as sorting. This is called as sorting. So data science and AI course is getting listed on my website Amos on 10th of September. Right? Please wait for that. We'll make sure that it does the trick. And also now coming back here, so we have understood that when you go and make use of sorting, it helps in getting the faster search. It helps in achieving the faster search. Let me give one more example. Let's say I randomly throw the numbers 2, 3, 1, 4, 5, 9, 6, 8, something like this. Now, if I go and tell you that, boss, this is a random arrangement of the numbers, can you make any meaning out of it? It will be tough. You can still find some meaning out of these numbers randomly arranged, but it will be tough. It will take a long time. But if assume that the same number was arranged in the increasing order, let's say that same number was arranged in the increasing order like below, right? For example, I have 1, then I have 2, then I have 3, then I have 4, then I have 5, then I have 6, then I have 8, then I have 9. Since it is an increasing order, I go and say that it is sorted. I can take some very quick decisions here. What is the minimum number? The minimum number is 1. What is the maximum number? The maximum number is 9. So when you are able to sort the data, you are able to always take a faster search and you are able to make a quick decision. So I wanted all of you people to know that sorting is important, sir. Sorting is important. And all of you by now should be clear that what is sorting and then why should I go and do the sorting. Is all of us equally convinced? Are we all clear that yes, sorting is important? And I think we all as a software developer should know it, because at the end of a day, we'll have to play with the data. And if I have to play with the data, I want to optimize it. I want the faster queries. I want to do the complex computation faster. And for that to happen, I need to go and make use of sorting. Am I clear, people? Does it make sense? Fair? So for the sorting, sir, till now, many people have given different type of algorithms. So the first set of the algorithm that we're going to learn is called as a comparison based. It's called as a comparison based sorting algorithm. When you try to compare the elements and then do the sorting, typically that's called as a comparison based sorting algorithm. They're also called as swapping based. So there are three different types of the comparison based sorting algorithms. They are first bubble sort. Second is called as a selection sort. And third is called as an insertion sort. Sometime people might ask you to directly write the code for the sorting algorithm. If you're still in the college, maybe in the exam, they will ask you the sorting algorithm code. But in most of the places, they will not ask you the code, that what is bubble sort, how do you write it? They will not ask you. But the logic that we go and apply, all the logic that we go and apply to solve it, that could be reused in all the problems. So my intention here is that to teach you people not just what bubble sort is, but what is the logic that we go and apply and how we can leverage that topic in all the other problems that we're going to solve ahead. Okay, so we'll start with the very first sorting algorithm called as a bubble sorting algorithm. Now, one of the beautiful thing about the bubble sorting algorithm is that it is being touted as the world's worst sorting algorithm. There's nothing more bad. There's nothing more worse than the bubble sorting algorithm. It is so bad that sometime in many of the universities, when they're teaching their UG students, the PG students, the bubble sorting algorithm, they don't teach actually, they skip this. Now, the question that might come to your mind is that if most of the universities are not teaching this, why is Vishwa teaching us? Why am I also not skipping this as a part of the course? That I'll tell you once we understand this bubble sort. See, one of the logic for teaching you bubble sort is that unless until you understand something is wrong, you will not be able to appreciate good. Right? So I first of all want you people to understand what is so wrong in bubble sorting algorithm that everyone is talking so crash about it. And number two, there's an enhanced version of bubble sort. So if you go and make a small change in the bubble sort, this becomes better than many other algorithms. So we'll talk about first of all the worst version of the bubble sort because of which the world hates. What is the logic? What is the code for it? And then we try to improve that in the today's session. Fair? So now let's get started. See, sir, my intention here is that I want you guys to be prepared for the top FANG companies. And when I go and say FANG, it's not only Facebook, Apple, Amazon, but typically any good product-based company who tries to get you a good package and who tests your concepts. Right? And for doing this, everything that we do, you should try to go and try to deeper into the concepts. So now when I'm starting teaching you the bubble sort, your intention should not be just understanding what is bubble sort. And I'm again repeating, what you should try to focus more upon is that how do I write the code? How do I develop that logic? How do I write that sense so that I can use that way of writing code in multiple other problem statements? Fair? So now let's start the bubble sorting. Bubble sort is an algorithm which has a previous word called as a bubble. So it has been inspired from something called as a water bubble. What is a water bubble? In the case if you guys have ever got to go and boil the water, right? Let's say that, there's a flame. The flame is just coming up and then I have water. So when you start boiling the water, you will realize what? Slowly the hotter droplets of the water goes up and the colder water comes down, right? So hot bubbles goes up and cold comes down, and then again the cold gets hotter, and that's how the whole heat is getting transmitted. This is how water typically is boiled. This is how the water is boiled. Fair. Water is boiled like this. Fair. Now, how do I go and solve this problem? So let's say that I have an array which looks something like this: 3, 5, 1, 2, 4. And I want to go and sort this using the bubble sort. So I just said bubble sort is inspired from this diagram where the hot water bubbles up and the cold water goes down. Right? The hot water goes up and the cold water goes down. So in this case also, in the bubble sort, my intention will be always to take the largest element to the rightmost position. The rightmost position. My intention would be to move the largest element to the rightmost position, right? So how do we do it? So first of all, what we start from the beginning: 3, 5, 1, 2, and 4. We start from the first position and we try to go and compare 3 and the 5. If left is less than right, I don't do anything. I move on. I move to the next stage, which is 3, 5, 1, 2, and 4. And I'm at this position. Now again, I compare left and right. Since left is more than right, I do a swapping. And on swapping, what I get? I get something called as 3, 1, 5, 2, 4. And I'm at this position. Again, what I do, I go and try to compare this and the next element. If the left is more than the right, it means it's not correct. So I go and swap it. So this becomes 3, 1, 2, 5, 4. And I'm at this position. Again, I go and compare 5 and 4. Since left is 5, right is 4, I need to go and swap. So this becomes 3, 1, 2, 4, and 5. So in this one iteration from here to here, my last element is fixed. My largest element has come to the right position. Now again, I am left with this array, which is 3, 1, 2, 4, and 5. In this position is already fixed. What I need to do now is that I need to care from here till here. And in this, I have to find the largest element which has to be kept to the right. So again, I start from here. I compare 3 and 1. I see the 3 is greater than 1 and still it is left. So I go and do a swap. So on the swapping, I get something called as 1, 3, 2, 4, and 5. I again try to compare here. I go and compare 3 and 2. 3 is more than 2. Again, the swap happens. So this becomes equals to 1, 2, 3, 4, 5, and I'm here. Now, since 3 and 4, when I go and compare 3 and 4, 3 is less than 4, I don't do anything. So with this now, these two positions are correct, and I need to take care of these 3 elements. Again, I go and take with 1, 2, 3, 4, and 5. These 2 elements are already in the position. I start with 1. Since 1 and 2, 1 is less than 2, nothing happens. Then I come here, 1, 2, 3, 4, 5. I am here, I compare 2 and 3. Since 2 and 3 are almost in the correct position, so nothing happens, and this only returns 1, 2, 3, 4, 5. Now I am done with all the 3 positions, and this is absolutely correct. One more time, I'll try to go and iterate. This is 1, 2, 3, 4, 5. I am here, I go and compare, nothing has to be done. So finally, I am left with 1, 2, 3, 4, and 5. And this is sorted. So this approach that we have tried, where every iteration, I would like to go and move the largest element to the right is called as a bubble sort. So basically, in the case of a bubble sort, what if there are n elements? Then I'll have to move these n elements to the right correct positions, right? So basically, I'll have to write an outer loop. So this loop will ensure that I'm running n times, and inside inner loop, this will ensure that the largest element is moving right. This should be the logic of the bubble sort. Am I clear, people? Does it make sense? Avatar, very nice. Is everyone clear on this? Is this logic clear to everyone? How it will work? So now let's quickly go and write the code for this, and we'll do a dry run. We'll quickly write a code for this, and we'll try to do the dry run. So what I go and open, I open my code. I have already created a folder called as sorting. Inside that, I've created a file called as bubble.js. Let me go and clear this console here. Okay. Now, what I do, let me go and define a function called as bubble sort, and it takes an array. Now, once I have done this, right? What I go and write is, I know that, let's say that I have an array, something that looks something like this. 3, 1, 5, 2, 4, something of this sort. I know that my first target is in the first iteration. In my first item, whatever is the largest element from here to here, I have to go and pick the move the largest to the last position. So inside this, what I need to do is that I'll write the outer loop. So outer loop makes sure we are running for all items, right? So I go and write for, and I go and say that I equals to array.length -1, I value is greater than 0, and then I minus minus. And the inner loop will move the largest at the ith index. So I'm starting my ith index from the last index, right? What I'm trying to do here from the outer loop is that I'm trying to start the ith index from the last index, because the last index should have the largest element. And then inside the inner loop, whatever is the elements present from the 0 till the ith index, I will go and put that in the ith index. So here inside this, I'll go and write the code, which looks something like this. For j equals to 0, j is less than I, j plus plus. So first of all, I go and compare the left and right elements. I go and say that if array I is more than array j, if that is the case, then I need to go and array j is more than array j plus 1 actually. If array left element is more than the right, it means that left is more than right. If left is more than right, then I need to go and swap. So what I need to do, I need to go and swap. And for swapping, I go and write something like this: array j, comma array j plus 1 equals to array j plus 1, comma array j. So if this is the case, then I go and swap it. And that's all the whole code. I think that's the whole code of the bubble sort. Let's try to run this code and see if it works. So let me go and define an array call as array equals to 5, 4, 3, 2, 1. And then I go and do a bubble sort. And I go and pass this array. And after doing this, let me go and do the console.log array. So if I go and run this node bubble.js, you see here my initial array was 5, 4, 3, 2, 1. But after I have called this function called bubble sort, it has sorted this. Been sorted in the ascending order. And because of this, my array has been printed as 1, 2, 3, 4, 5. Let's take the code and do a dry run so that all of us get crystal clear and we don't have any doubts left. So let me do this here. Let me paste it here. So this is a bubble sort code. Let's say that I want to go and run it for the following say. Let's say that I'm trying to sort something called as bubble sort, and I go and pass 4, 3, 2, 1. Right. So my array here is 4, 3, 2, 1. Now what I do, I start from the, so basically what I need to do, I need first in the first iteration, when I value is equals to, what is this I value? I value is equals to length is equals to 3. So first time in the running, I value is equals to 3. And what my intention is, if I consider 0, 1, 2, 3, at the ith index, I have to put the largest element. This is what I want to achieve. So for the first time when the outer loop is running, I value is equals to 3, and then I have an inner loop. So inner loop runs for j equals to, it has to run from j equals to 0 till j value is less than I. So it should have to go till 2. So first of all, I go and see for the j equals to 0. J equals to 0, I have the element 4. So I go and compare j and j plus 1. 4 is more than 3. So what happens? The swapping should happen. This should happen. So when at j equals to 0, this array gets changed to 3, 4, 2, 1. Then again the next time j equals to 1. J equals to 1, I am here. I go and compare these two. Again, I see that 4 is more than 2. Swapping happens. So at this time, this gets changed to 3, 2, 4, 1. Then again j equals to 2. I am here. I again compare 4 and 1, and again it is more, so it has to be swapped. So this becomes 3, 2, 1, 4. And if you see here, by this time the inner for loop is done. I have got the array transformed as 3, 2, 1, 4, and this is at the correct position. The largest element has come to the rightmost point. I move next. I form to I equals to 2, the next iteration. Again, when the I is equal to 2, j value will range from, in this case, j value should start from 0 and should get to 1, because j value should be less than 1. Now, let me go and do it. When the j value is equals to 0, this is where I am, 3, 2, 1, 4. I am here. I compared 3 and 2. 3 and 2 is more, so I get swapped. So at this position, it changed to 2, 3, 1, 4. Again, j equals to 1. I'm here. I compared 3 and 1. 3 is more than 1, so swapping will happen, and this results in 2, 1, 3, 4. So after this is done, my current state of the array is 3. My current state of the array is 2, 1, 3, 4, where last two elements are at the correct positions. Then again go and run it for the I is equals to 1. I is equals to 1. And at this point of time, again my j value is 0, and it should be only be 0 because it has to be less than 1. So for j equals to 0, I am at this position 2, 1, 3, 4. I am at this position. I compare 2 and 1. 2 is more than 1, so I go and swap. So it becomes 1, 2, 3, 4. I am done. This I loop is also done. Finally, what I've got is 1, 2, 3, 4, which is sorted. So this is how the bubble sorting works. Am I clear, people? Is everyone clear till this point? Is everyone clear with the bubble sort? Is everyone crystal clear? For those people who are joining late, please make sure that you're watching it and you have converted it. So if I have to nutshell, I have to go do the summary. Let's say that is 3, 1, 2, 5, 4, right? What we need to do is that first of all, I have to iterate from here to here and find the make sure that the largest element moves to the right. How do we do it? We first of all compare 3 and 1. 3 and 1, 3 is more, so I make 1, 3 here, then 2, 5, 4. Again, I compare 2 and 3. 3 is more, so I again swap 1, 2, 3, 5, 4. Then I go and compare 3 and 5, nothing will be done. Then I go and compare 5 and 4, and it will be swapped. So I'm done with this line. Then the next iteration I'm left with 1, 2, 3, 4, 5, where 5 is done. Now again compare 1 and 2, nothing happens. I came here 1, 2, 3, 4, 5. I compare 2 and 3, nothing happens. I again move to the next steps 1, 2, 3, 4, 5. Again compare 3 and 4, nothing happens. I move to the next, which is 1, 2, 3, 4, and 5. I'm done. 2 steps are clear. Then in the next step, I have 1, 2, 3, 4, 5. Again, start from here, compare, nothing has to be done. I move to the 1, 2, 3, 4, 5. Again, I compare, nothing has to be done. I do 1, 2, 3, 4, 5. I'm done with all these 3. Then finally, I'm left with 1, 2, 3, 4, 5. I do 1, 2, 3, 4, 5. These 4 are already done. I have to compare these 2, and then it becomes 1, 2, 3, 4, 5. So this is how the bubble sort works, people. This is how the bubble sort works. Am I clear, people? Am I clear till this point? Does it make sense to everyone? Is everyone clear, people? Yes, no? All good? So now let's try to analyze this code. If I go and open my code, we copy this and paste it here. Let's start analyzing this code now. Let's try to see that. What will be the time complexity of this? Time complexity. What will be the time complexity of this algorithm, boss? The first loop runs for n times. The second also almost runs for n times. So the time complexity will be how much? It will be order of n square. Okay. So time complexity is order of n square. The second one is called as space complexity. How much is the space complexity? How much will be the space complexity? So for sorting this array, I'm not using any extra space. Since I'm not using any extra space, so space complexity will be called as order of 1, or I go and say that it is constant. So any sorting algorithm where the space complexity is constant or order of 1, that's called as a in place algorithm. That's called as in place algorithm. The first one is time complexity. The second one is the space complexity. Time complexity is order of n square. Space complexity is constant. Okay. Now another question for you people is that what are the now how many comparisons is in the entire code? How many comparisons will happen? Focus at the code here and you tell me how many comparisons is happening. Where is the comparison happening? The comparison is happening here in this if block. So if I go and ask you in this entire code base, how many times the comparisons are happening, what will you tell me? So the number of comparisons is equal to number of times the loop is running. So the number of time comparison is directly proportional to the n square time. Am I right? The number of comparisons will be proportional to the n square. Binary, you are right, but it will be proportional to the n square time. Correct? Very nice. In the worst case, if I go and talk about in the worst case, how many times the swapping will happen? How many times? In the worst case, how many times the swaps will happen, sir? Where is the swapping happening? The swapping is happening here. So in the worst case, every time you do a comparison, you find that I need to go and swap it. So the swapping will happen also proportional to n square. Now a question for you people is that what is that worst case? Which type of array you will say that it will have a worst case where I'll have to go and do the swapping all the time? Can you give me an example of that array? In which type of the array we have to do the swapping all the time? What will be that? What nature of the array will need that every step very time? Not the unsorted, it should be, it should be descending order. Let's say that if I have an array which is exactly descending 5, 4, 3, 2, 1. So if an array is descending, or I can either say that reverse sorted. If the array is descending or reverse sorted, in that case, I'll take the maximum number of swap, which is equals to n square. Now, because in the case of bubble sort, everything is n square. Time complexity is order of n square. Swaps is proportional to n square. Comparison is proportional to n square. This is considered to be the worst sorting algorithm. This is considered to be the worst sorting algorithm. Now, tell me one thing. Let's say that if I go and call a bubble sort and pass a already sorted array something like this 1, 2, 3, 4, 5. Even if you go and pass the already sorted array, the code that we have written, right? If I go and paste the code that I have written, which is there on the screen. Even if I go and pass in this bubble sorted array, a already sorted array, what will be the time complexity in this case? What will be the time complexity in this case? Even if you go and pass the sorted array to a bubble sort, what will be the time complexity here, sir? It will still be O of n square. It will still be order of n square only. Because even if it is sorted, I will go through this entire loop. I'll go through this entire for loop. So total number of operations will be n square. And that's where, it's a very important question. Many of times I have seen Google asking this question. So Google says that, what should I make change in this code? What change? And I cannot make change in any structure of the for loop or something. I cannot change it. What is a small tweak that I can do so that this bubble sort becomes O of n time complexity in case of sorted or nearly sorted array? What should I do to this bubble sorting algorithm so that the bubble sorting algorithm time complexity either becomes, it should become linear in the case if it is sorted array or the nearly sorted array. Right, I'll write the code here and I want you guys to give it a try. So let me move to the next page. I have this code here. My question for you people, my dear friends, put that into the comments if you are able to solve this. What change should I do in this code? What change? For example, at this moment of time, if I go and call this bubble sort and pass 1, 2, 3, 4, 5, even though it is already sorted, it will still take order of n square time. So what change should I do in this bubble sort that if I go and try to call this should be done in order of n time itself? I should save some time. Any suggestions? Very nice. The change that we can do here is a concept called of using flag. Let's try to see that how we can do it. Let me go and open my VS Code. And what we do here is that let me go and copy this function. And I may go and put it here. Bubble sort optimized. What we do here is that we go and keep a flag called as let is sorted equals to true. In the beginning, I assume that the array is already sorted. Then I go and try to iterate over the array. Now, any time while I'm iterating inside the array, if I find that left is more than right, it means that it was not sorted. So I go and change this Boolean value is sorted equals to true. And after running with this for loop, and after running for the entire for loop, when I come out, I go and check if is sorted. If it is still true, it means that none of the element in the entire array was disturbed. So I can simply go and return in that case. Let me copy this code and explain you with the dry run. So if you try to see the code here, boss, what is happening? See, this outer for loop is just iterating through the elements, right? It is the inner loop. It is the inner loop which is iterating all the elements of array. And how we are iterating? Let's say that I have element called A1, A2, A3 till AN. We are iterating like this. We are comparing two elements, then we are comparing two elements, then we are comparing two elements. So we're comparing all adjacent elements. So before we start comparing, I assumed that this array is already sorted. So I go and set the value as true itself. And then when I start comparing, if at any moment of time I find that left is more than right, any moment I find that left is more than right, it means that the array was not sorted, because if it is sorted, if an array is sorted like this, 3, 5, 9, 12, 16, all the elements to the left will be smaller than the right itself. But at any moment, if I go and find that, boss, no, left is more than the right, it means that array is not sorted, and I go and set the flag as false. But let's assume that I go through this entire for loop. It means that I have completely iterated. And after the iteration also, this is still true. This is still true. It means that array is already in the sorted order. I don't need to do anything, and that's it. I can return from here. So just adding this flag, the best case time complexity of bubble sort becomes equals to order of n. Am I clear, people? So what a takeaway from this? Even though the bubble sort is worst, but in certain situations definitely could be used. So in the case you have a sorted array or nearly sorted array, in this case, one of the best algorithms to use will be the bubble sort. In spite of all the other modern, advanced, sophisticated sorting algorithm, bubble sort still makes use of when we have the sorted or non-sorted or nearly sorted arrays. Just like the real world, everyone has some talent unless until you know how to utilize them. You should never feel that someone is totally pathetic, he or she cannot do anything. Everyone is talented in their own unique way. Similarly, bubbles, so that it's very pathetic. Most of the universities don't actually teach them in the colleges. But if we just slightly motivate them, slightly modify them, for the sorted and nearly sorted arrays, there is no other algorithm in the world which is better than the bubble sort algorithms. Nearly sorted means that, let's say that it is already 1, 2, 4, 3, 5. If you see here, it's almost sorted. Almost sorted. Only this elements, if I go and change, this becomes sorted. So only if few elements are misplaced, I go and say that nearly sorted. Nearly sorted means only few elements are misplaced. Am I clear, people? Does it make sense? Is everyone clear till this point, guys? Is flag, if you see here, only when it does not go inside this if block, I am going to say that it is sorted. If it goes inside this if block, then only it is set as false. If only if the entire for loop is run and it does not go inside the if block, I can say that array is sorted. And if the array is sorted, then I go and return this. Avatar, am I clear? Does it make sense? Everyone here in the class? Yes, Ayush, absolutely. So let's try to take this example of Avatar 1, 2, 1, 2, 4, 3, 5. Okay, let's try to see that why I'm saying that it's taking the better time complexity. Let's take that example. Right. Let's try to run this for 1, 2, 4, 3. Let me go and call this for array value is 1, 2, 4, 3. This is a nearly sorted array. Now, the first time when it is running, what I value is equals to 0, 1, 2, 3. I value is equals to 3. Inside this, what has happened is sorted equals to true. Okay, this value is set, and then this for loop starts. When the for loop starts inner, what will happen is that I go and set the value j value equals to 0. And at this time it is 1, 2, 4, 3. I go and compare 1 and 2. Nothing happens. Again, I go and do j equals to 1. I'm here. I compare 2 and 4. Nothing happens. Then I go and do j equals to 2. I come here. I compare 4 and 3. When I go and compare 4 and 3, this holds true. So I come here. So at this point is sorted value becomes equals to false. Right? And then what we do? We go and swap. So after doing this, this array gets transformed to 1, 2, 3, 4. The next time the loop runs, which is equals to I is equals to 2. Now at this time again j value is equals to 0. I have 1, 2, 3. And again this is sorted value will become true. Right? Inside this is sorted is equals to true. J equals to 2, nothing happens. J equals to 1, again 1, 2, 3, compare 2, 3, nothing happens. J, perfect. So I went through the entire for loop, but this is sorted is still true. So from here, this lines gets executed and I return. So what will happen? The outer for loop does not run for the entire time. It only ran twice. So I'll still say that it will have the linear time complexity. Fair enough, Avatar, and everyone in the class, guys. Are we cool here? Are we cool here? Cool. So now since we have understood, let me talk about one more concept to you guys, which is called as a concept of the stable sorting. What is the meaning of a stable sort or unstable sort? Let's say that I have a repeated elements. For example, I have something called as 2, 1, 3, 1, 4, 5. Okay. And let's say since I have two I, so I go and represent one I with the one I dash. So when I go and sort this, there are two possibilities that will happen. One of the possibilities is that 1 dash, 2, 3, 4, 5. And another possibility is 1 dash, 1, 2, 3, 4, 5. Now if you see here, sir, this is also sorted. And if you see here, this is also sorted. But there's a difference. In my original, 1 was before 1 dash. Here also 1 is before the 1 dash. So the relative order is same. Relative order, same. Here 1 dash have come before, 1 has become, relative order has changed. So when you do the ordering, when you do the sorting, for the equal elements, when the relative order remains same before sorting, same after the sorting, I go and say that this algorithm is called as a stable sorting algorithm. Stable sorting algorithm. In the case if this is not holding true, the relative order of equal elements changes after the sorting, I go and say that it is a unstable sorting. Am I clear, people? The meaning of the stable sort and unstable sort? In the stable sort, after sorting, relative order, equal elements remain same. In the stable sort, after sorting, relative order of equal elements remains the same. Fair enough? Am I clear, everyone? Is everyone clear on the stable and unstable sorting? I want you people to be crystal clear today itself, so that in the future, we write the code and I ask you the question, it is stable or unstable, you should be able to answer that. Is everyone clear what is stable sorting? Great. So now since you have understood what is a stable sorting, this is the code which is there on your screen now. This is a bubble sort code. I want you people to think and tell me if it is a stable sort or it is an unstable sort. And you have to go and tell me the reason. You have to go and tell me the reason why you are saying that it is stable or the unstable sort. Think and put that into the comments. Tell me, what do you think? Is bubble sort a stable sorting algorithm or an unstable sorting algorithm? If it is unstable, why do you think so? And if it is stable, why do you think so? What do you guys think? Put that into the chat. Is a bubble sort a stable sorting algorithm or it's an unstable sorting algorithm? What is that, people? Very nice. I think most of you have got it right. Why it is stable? It is stable because, see, anything stability will be impacted by the swapping, right? Stability will always be impacted by the swapping. Now you're doing the swapping only if the left is more than the right. Only when it is unequal, then only you are doing the swapping. You are not doing the swapping when it is equal. So when it is equal, since you are not doing the swapping, so for the equal elements, relative position will not change. Relative position will not change. And that's why this is a stable sorting algorithm. I'm again repeating. The swapping. See, when the position of the elements will change, the position of the element will change only when you do the swapping. And in the bubble sort, I'm doing swapping only if two elements are unequal. That is, left is more than the right. If the two elements are equal, boss, we are not doing any kind of swapping. So for the equal elements, if the no swapping is happening, the relative order is not going to change. And if the relative order is not going to change, it is an example of a stable sort algorithm. It is an example of a stable sort algorithm. Am I clear, people? Does it make sense? Boliye. Am I clear? Cool. So now, since we are done with the bubble sort algorithm, what I'll do now is that I want you people to actually go through this video one more time if you're not very clear. And then I will have some assignment problems. Assignment problems. Especially on this bubble sort. Where will you get this assignment problem? This assignment problem you'll get on the WhatsApp community. So if you have not joined the WhatsApp community, please do go and join it. You will find the description link here. In the WhatsApp community, we have tried to arrange the content well, right? So there you will have a single seat where for each day live sessions, we have the assignment, solution, everything being placed there. So make sure that you have joined this, go and follow the problems, solve those out. And in the next session, we'll move to the next topic, which is the selection sort. Thank you people for all the love. We are going great. In the coming few days, I am planning to add more courses on our English channel, which include the Python track, data science track, and much more. But one thing which I want to announce all you people, and I want you people to go and tell your friends, at Amers on the occasion of 5th September, Teachers' Day, I take a lot of pride. I feel great for all the support that you have given me. As a return to my community, we have started a 7-day live workshop. What we do in this 7-day live workshop? In the 7-day live workshop, we teach you 7 days about how to be well prepared for the interviews. Talk about the LinkedIn, talk about the resume, talk about the soft skills, talk about, tell me about yourself, tell about what to behave, how to react, even if you don't know the questions on the interviews, soft skills, aptitude, puzzles, everything. Also, you get to make your resume on our AI powered portal. Also, you get the unlimited mock interviews. You can go and check out our job portal. And also the top performers of this week will also get the job and internship opportunities. All of this we wanted to actually keep it for free, but we know that if we make it zero, my so much healthy competitors, they will go and write bot and just flood my database with the crap data. So we had to attach some small amount so that at least these people will not write a script to spam our database. So that's why I have just kept a very token amount, which is just 149 rupees. And you get access, unlimited access to my AI powered platform for the next 7 days, unlimited number of mock interviews you can do. You have the access to the job portal, and this is for a very limited period, right? So make sure that you guys are making the best of this opportunity. Talk to your friends, colleagues, seniors, juniors, tell them about this. I want the India to make the best use of this time. Limited seats available. but this is the best that I can do for you people on this occasion. Said that, I'll see you again in the next class. We'll talk more, we'll solve more problems. Thank you for learning. Good night, take care and stay safe. Yes, and this is called as Taiyari job key. This is called as Taiyari job key. Go and tell your friends, ask everyone to enroll. Let's together make the best out of this live workshops. It's only for one time, it's not a repeat batch. So let's nail this time itself. Thank you, everyone. Good night.